This is 7-1, ratios in similar polygons. So in our last chapter, we talked about triangle congruence, and now we're going to be talking about similarity rather than congruence. Let's take a look at the warm-up. Number 1, if triangle QRS is congruent to triangle ZYX, identify the pairs of congruent angles and congruent sides. So our angles would be angle Q is congruent to angle Z, angle R is congruent to angle Y, angle S is congruent to angle X. And then for sides, we would have side QR, segment QR, is congruent to segment ZY. Segment RS is congruent to segment YX. And segment QS is congruent to segment ZX. Solving the proportion. To solve proportions, we cross-multiply. But just remember that we're multiplying times a binomial here, so it's 8 times x minus 3. That's going to be distributive property. And 2 times 3x minus 3. So now I distribute. And get the variables to the same side. Isolate the variable. X equals 9. We can check our work on these as well. If we plug in 9 into the x positions here and calculate and simplify the fractions, you would get that 1/3 equals 1/3. So I know that x equals 9 is correct. Try number 3, pause the video, and hit play when you're ready to see the answer. I got x equals 18, and I plugged in my x equals 18 into both x's in the original proportion, and I ended up with 12 over 42 equals 22 over 27, which I knew was true because I just changed this fraction, this unsimplified fraction, to a decimal, and I got 0.286 rounded, and I got the same thing when I changed 22 over 77 to a decimal. Okay, figures that have the same shape but are not the same size are called similar. And this probably looks familiar to you. Can you think of a transformation that ended up looking like this? And that would be a dilation. So dilation creates a similar figure. They're the same shape, but they're not the same size. And we use the top of a congruent symbol to indicate similarity. So similarity has this symbol, and congruence has an equal sign with the similarity symbol on top. So we're going to talk a lot about the difference between congruent and similar. Remember that congruent has the same shape and the same size. Everything about it is the same. Similarity has the same shape but not the same size, like a dilated figure. In order to see if something's similar, we need to know that the angles are congruent. To see if something is similar, which remember only has the top of a congruent symbol, the similar symbol, the angles must be congruent and the sides must be proportional. Before we needed angles and sides congruent. Now we need angles congruent, sides proportional. Proportional and similar go hand in hand. Two polygons are similar polygons if and only if their corresponding angles are congruent and their corresponding side lengths are proportional. So let's see what that means. So we need angles that are congruent. And I know that in example 1, angle N is congruent to angle Q because that's given to us with the 90-degree angle. We also know that angle P is congruent to angle R because of the definition of congruent. These are the same angle, so they're congruent. And now I know that angle M is congruent to angle T because of third angle theorem. If two triangles are congruent, then the third angle must be congruent. So I know that the angles are congruent to each other. Now we need to know that the sides are proportional. So NP is supposed to match QR. And MN, which is in between the one mark I made and the right angle, the one mark on the right angle, matches QT. So So that would be 2 over 1. If I go from left to right, I can put this 2 over the 1. And then I also know that the 2.2 would go over the 1.1. And so I need to see if this is true. The way that I see if it's true is I just cross multiply. 2 times 1.1 is 2.2, and 1 times 2.2 is 2.2. Since these cross products equal each other, then these are proportional. So we have congruent angles, and this showed proportional sides. So take a minute to show that these triangles are similar. We know that angle Z is congruent to angle R because they both have the same amount of arc marks. Angle Y is congruent to angle Q because they have the same amount of arc marks. And we know that angle X is congruent to angle S because of the third angles theorem. So our angles are congruent. Angles congruent. Now we need sides proportional. So if you look, this image, SQSR, really needs to flip around so that it lines up. This one arc mark needs to match Z. So if I just redraw it real quick, it would be that R is matching Z, Q should be where the Y is, and S should remain up top like the X. And so I can put in my side lengths. RS, according to the image, is 13.5. So I'm just kind of flipping this around. SQ is 9 and QR is 18. So now it's so easy to just match the sides. So I know that the 9 is supposed to go with the 13.5. So I can do 9 over 13.5 equals, and 6 would go over 9, equals 6 over 9. And remember, you can cross multiply. So 9 times 9 is 81. 13.5 times 6 is 81. These cross products are equal to each other. So I know that the sides are proportional. Since this is the case, we have congruent angles, sides that are proportional. These two check marks mean that we have similar figures. If two polygons are similar, we can calculate the similarity ratio by dividing the lengths of the two corresponding sides. So ABC to DEF, so I'm looking to the left first, ABC over DEF. It looks like one side's 3 over 6. 3 over 6, and we simplify that, we get 1/2. Now the similarity ratio of triangle DEF to triangle ABC. So DEF to ABC would be 6 over 3 instead. See the difference there? DEF was on the right going to the left, so I have to start with the right side's side length first. So 6 over 3, which equals 2 over 1. Either of these would be acceptable for my similarity ratio. Determine whether the polygons are similar. If so, write the similarity ratio in a similarity statement. Okay, rectangles. Since these are rectangles, I actually know all the angles are 90 degrees. So I already know all the angles are congruent to each other. So I'm good with angles. My angles are congruent. Next, I'm looking at proportional sides. So we're going from ABCD to EFGH. So that would be 9 over 6 is equal to 6 over 4. Let's see if that's true. You can cross multiply. 9 times 4 is 36. 6 times 6 is 36. Since we got 36 equals 36, we also know the sides are proportional. Okay, how about triangle PQR and STW? PQR and STW. Okay, since these are isosceles triangles, the base angles are congruent to each other. So if this is 36, we could subtract 180 minus 36, and we get 144. And we divide that by 2, so we get 72 for each base angle. And the same thing on the other side. Since STW is isosceles, these would be 62 degrees each. That means we've used 124, and we have 56 degrees left for angle T. And so already the angles are not congruent. So triangle PQR is not similar to triangle STW. Now you try. You should never assume in geometry, so I'm going to tell you that these are rectangles. So again, I know that all the angles are congruent already. Let's check our side lengths to see if they're proportional. So PQ to TU, that would be 12 over 16, is equal to 4 over 6. And let's just double check. Notice my diagonals, my proportion is not proportional. The diagonals, cross products, do not equal each other. 72 does not equal 64. So therefore, these triangles are not similar. Rectangles, sorry. So rectangle PQRS is not similar to rectangle TUVW. Okay, so in example B, we have the angle A is congruent to angle D. Angle B is congruent to angle E. And so angle C must be congruent to angle F because of the third angles theorem. Now let's check some sides. So notice my side that I'm looking at first, this 15, is in between the 1 and 2 arc marks. So in between the 1 and 2 is 20. So I'm going to do 15 over 20 is equal to, and then I'm going to check another side. So I have 12, which is in between the 3 and 1 arc mark. So in between the 3 and 1 would be 16. So I would have 12 over 16. And you can simplify or you can calculate the cross product. Since I got 240 on each side for my cross products, then I know that these triangles are definitely similar. We have to be careful how we label our similar triangles. So for instance, if I say triangle DEF is similar to, notice I went 1 arc mark, 2 arc marks, 3 arc marks. So I'm going to find 1 arc mark, which is A, triangle A, 2 arc marks, which is B, and 3, which is C. So triangle DEF is similar to triangle ABC. This is because all angles are congruent and all sides are proportional. In example 3, we can write a proportion. So 5 over x is equal to 1.8 over 6.3. Cross multiply and solve. I got x equals 17.5 for that. So 17.5 meters. Okay, for the now you try, we've got 2 inch for the width and 7 inch for the length. And we're told that the length of the actual boxcar is 50 feet. So the length would go together. And the width, we'll call that separate. And you don't need to convert when you set up these proportions. So I've got my 50 feet for my length. Picture that as the real train would be 50 feet. And that matches up with the 7 inches. So over 7 inches is equal to, and I don't have my other side, so we'll call that x over 2 inches. And if we cross multiply, we get 100 feet inches. I know that sounds funny, but just bear with me. Equals 7 inches x, divide both sides by 7 inches. That means that the inches cancel out. 7 over 7 is 1. And so we end up with 100 feet over 7. And if you divide 100, you get about 14.3